This time we are going to look at graphing trigonometric functions. So to graph trigonometric functions, it's always good to start with sines and cosines. So let's start with a function like f of x is equal to 2 sine 2x minus pi. And when we think about the sine of an angle, the easiest angles for us to figure out what those values are the angles that lie on the unit circle, on the axes on the unit circle, because this point is 1, 0. This is 0, 1, negative 1, 0, and 0, negative 1. And so if we think about building a chart of angles, we're going to start with the angle theta. And for the first one, we'll be looking at theta being equal to 0. That gives me this first location. Then the angle theta equal pi over 2, which gives me this location up here. Then the angle pi, which gets me out to this location. And the angle 3 pi over 2, which gives me this angle. And I like to go ahead and also put in 2 pi to get me back around to where I started. Now we need to figure out what x value gives us each of these angles. So the first thing to notice is to get angle 0, my x needs to be, well, 2x minus pi has to equal 0. So my x has to equal pi over 2. So this happens from pi over 2. The next angle, the next x that gives me the pi over 2 angle, says that 2x minus pi is equal to pi over 2. So 2x is equal to 3 pi over 2, or x is equal to 3 pi over 4. And these are going to be evenly split, or evenly separated out, because it's the same amount change in x is going to give me the same change in the angle. So I'm going to rethink about this pi over 2 as 2 pi over 4. Then I can see that every pi over 4, I'm going to get to the next angle. So theta being pi would come from x being 4 pi over 4, or just pi. Theta being 3 pi over 2 would come from x being 5 pi over 4. And theta being 2 pi would come from x being 6 pi over 4, or 3 pi over 2. Now, the sine of theta is going to be equal to the sine of 2x minus pi. So the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. And the sine of 2 pi is 0. This gives me a y value of, well, I'm multiplying the sine of theta by 2. So this gives me a y value of 0, 2, 0, negative 2, 0. This allows me to start to draw a graph. So if I start drawing a graph, every pi over 4 is what is mattering to me. So I put pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, etc. and it works the same way the other direction. And we can just keep going as far as we want. The y values are going to be coming out at between -2 and 2. So at x equal pi over 2, we are getting a y value of 0. At x equal 3 pi over 4, we're getting a y value of 2. At x equals pi, we're getting a value of 0. At x equals 5 pi over 4, we're getting a value of -2. And at x equals 3 pi over 2, we're getting a value of 0. This pattern is just going to keep going as you go around the circle however many times. And it also works going the other direction around the circle. So we get something that looks like this. If we graph this, it's just going to be connecting these in a nice curve. And so that is the graph of f of x, which is 2 sine of 2x minus pi. The things that are super significant here is when we're graphing sines or cosines, we're looking at the angle theta being each of these edge of the quadrant angles. And since we're looking at those angles, we have to figure out what x value gives us those angles. Then we can use that to figure out what the y value is. This same process will work for cosine, except for cosine of 0 would be 1. So that's how we graph sines and cosines. If we want to graph a tangent, we do follow the same basic process. So graphing tangents and cotangents, we're going to be doing basically the same thing. So let's look at the function g of x is equal to tangent of x plus pi over 2 plus, let's just leave it at tangent of x plus pi over 2. If we're looking at the tangent of x plus pi over 2, if we think about the tangent, and we draw the unit circle, that's a really bad unit circle, then the tangent of theta is sine of theta over cosine of theta. So we're going to have these same quadrant angles are going to be meaningful, but this spot right in the middle of each of these is going to have the same value of sine and cosine, so those are going to give us 1s as tangent values. So those are also going to be helpful for us. So if we're looking at the tangent of x plus pi over 2, our angle theta, we're letting theta equal x plus pi over 2. Our angle theta, the thetas that we care about, are 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. For each of these angles, we're going to get an x value that gives us that angle. And so for 0, that x value is going to be negative pi over 2. For pi over 4, that x value is going to be negative pi over 4. For pi over 2, the x value is going to be 0. For 3 pi over 4, the x value is going to be pi over 4. For pi, the x value is going to be pi over 2. For 5 pi over 4, the x value is going to be 3 pi over 4. For 3 pi over 2, the x value is going to be pi. For 7 pi over 4, the x value is going to be 5 pi over 4. And for 2 pi, the x value is going to be 3 pi over 2. And this will give us y values of, well, for tangent of 0, we're talking about the sine being 0, the cosine being 1, so that gives me 0 over 1 is 0. For pi over 4, the tangent of pi over 4 is 1. The tangent of pi over 2 is the sine of pi over 2 over the cosine of pi over 2 is 1 over 0. That's undefined. For the tangent of 3 pi over 4, we get negative 1, 0, 1, undefined, negative 1, 0. And so each of these undefined locations is going to represent a vertical asymptote. So if we graph this function, we're going to we care about values from negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, and 2 pi, and 3 pi over 2, and it will keep going, following the same patterns. The first thing I like to graph is to list all the asymptotes. So my first asymptote is coming at 0, at x equals 0, which is coming from this line. The next asymptote is coming when x is equal to pi, coming from this line. And that process will repeat. So the next one would be right here. And the next one would be back here somewhere. And that we would keep going forever. So we're going to go from this point, and now we're going to graph plot the other points. So at negative pi over 2, we get 0. At negative pi over 4, we get 1. At pi over 4, we get negative 1. At pi over 2, we get 0. At pi over 4, we get 1. At 5 pi over 4, we get negative 1. 3 pi over 2, we get 0. And this pattern continues. And so if we graph this, what we'll see is something that's looking like this. And that is what the tangent function looks like. Let's do one more type of function. Let's look at a secant function. For that, we're going to be looking at the function f of x is equal to the secant of, let's say, 2x. Now, the secant of theta is equal to 1 over the cosine of theta, so there's a related graph that is a cosine graph. And we're going to go ahead and graph both the secant graph and the cosine graph together. So to do that, we are going to think about where are the significant points on a cosine graph, because those are going to be the most significant points on the secant graph as well. And that's happening at each axis. And so the thetas that we care about will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And those thetas come from x values of 0, pi over 4, pi over 2, 3 pi over 4, and pi. So then for the cosine graph, this gives us a y value of 1, 0, negative 1, 0, 1. For the secant graph, it gives us y values of, well, 1 over 1 gives us 1. 1 over 0 is undefined. 1 over negative 1 gives us negative 1. 1 over 0 is undefined. And 1 over 1 gives us 1. So if we're graphing this, we're going to be looking at x values of 0, pi over 4, pi over 2, 3 pi over 4, pi, and it will keep going in both directions. For the cosine graph, this gives us points that look like 0, 1, 0, negative 1, 0, and it will continue in both directions and give us the graph that looks like this. Now for the secant graph, everywhere where the cosine is 0, we're dividing by 0 when we take the secant. So those are representing vertical asymptotes. And so we draw in the vertical asymptotes, and then we're going to go ahead and plot the few points that we have, which are just these peaks and valleys of the cosine graph. And as you get close to an asymptote, the y value gets very close to 0. When you're dividing by something very close to 0, you get a very large number. So the secant value is getting close to infinity. If the y value of the cosine graph is positive, you're getting close to positive infinity. If the cosine value is negative, you're dividing by something close to 0 but negative, so you're getting negative infinity. And that means that our graph is looking like this. And that pattern will continue in both directions. And that is what the secant graph looks like.